Dear students, this tutorial video is an introduction into discounted cash flows. Aim of this introduction is to give you a sound understanding of the discounted cash flow methodology applied in company valuation. Dependent on the valuation paradigm, a different free cash flow and discount rate is required. For a valuation based on enterprise value, the free cash flow enterprise value and the weighted average cost of capital WACC is chosen. For an equity-based valuation, the free cash flow equity is applied and the required discount rate is the cost of equity K equity. A neutral approach is based on the free cash flow and the discount rate K. Later in this course, we will learn how to determine these free cash flows and the respective discount rates. The mathematical approach we use to determine the value of a company with a DCF approach is the net present value formula, where a stream of infinite future cash flows, FCF, is discounted at the discount rate 1 plus K. This infinite sum can be written as the free cash flow in period 1 divided by 1 plus K plus the free cash flow in period 2 divided by 1 plus K to the power of 2 plus the free cash flow in period 3 divided by 1 plus K to the power of 3 and so on. To apply this formula in practice, we have to make different assumptions, which will be illustrated on the next slide. Two assumptions are made to use the infinite present value formula in a simple way. We assume either constant perpetual free cash flows or perpetual cash flows growing at a constant rate. These assumptions allow us to write the basic present value formula as an infinite geometric series, which can further be simplified to the following two expressions. Assuming now a perpetual free cash flow of 1 million and a discount rate K of 10%, we obtain a company value of 10 million. When we further assume a constant free cash flow growth of 2%, the company value will be 12.5 million. This table illustrates the time impact of discounting under the perpetual assumption. The further the free cash flow lies in the future, the lower is its present value and its contribution to the company value. For example, the value of a free cash flow payment of 1 million in 1 year has a present value of 909,091 and the associated share of value is 9.1%. However, a payment of 1 million in 80 years has a present value of only 488 and contributes virtually zero to the value of the company. Based on the insights of the previous slides, we recognize that 37.9% of the company value incur in year 1 to 5. Moreover, 85.1% of the company value incur in year 1 to 20. These numbers illustrate that the assumption of constant free cash flows might not be appropriate, since the company value depends to a large extent of the early cash flows. On the previous slide, we recognize that the more detailed planning of the cash flow incurring in the first 3 to 7 years seems to be most relevant in order to determine the company value. After this planning period, we assume either a constant perpetual free cash flow or a perpetual free cash flow with constant growth. How does the DCF valuation formula look like when we assume a planning period of t equal 3 years and a residual value period starting in year t plus 1 equal 4? In the planning period, we discount the free cash flows according to the standard present value formula. For the residual value period, we apply the terminal value formula to determine the value of the perpetual cash flows starting in year 4. Note that we have to discount the terminal value with 1 plus K to the t to obtain the present value. The sum of these computations yield the company value. Let us look now at a more concrete example. For that purpose, suppose a discount rate of K equal 10%. The free cash flow in the first year is 10, the free cash flow in the second year is 12, and the free cash flow in the third year, the final year of the planning period, is assumed to be 14. Substituting these numbers in the present value formula, we obtain a company value of 29.53. In a second step, we compute the discounted terminal value, which considers the residual value period starting in year 4. In this context, we assume a constant perpetual free cash flow of 13. Applying the discounted terminal value formula yields a value of 97.67. The sum of 29.53 and 97.67 equals the company value of 127.2. So far, we introduced the DCF approach to company valuation and understand how to apply the method. Now let's test what we've learned so far in a little exercise. Assume the free cash flow in year 1 is 100, and in year 2 we forecast a free cash flow of 105. Moreover, from the second year onwards, we assume a constant free cash flow growth at the rate of g equal 2% in perpetuity. We estimate a discount rate of k equals 7%. Based on these numbers, what is the value of the company? In order to determine the company value in the previous exercise, we apply the evaluation formula with growth. Substituting the corresponding numbers and getting the math done right, we obtain a company value of 2056.07. In the previous example, we have made an assumption about the rate at which free cash flows grow in the future. This assumption has an important impact on company valuation since larger growth rates of future free cash flow are associated with larger company values. Let us look at this result in detail. The below table provides an overview of company values where different growth rates have been used. For instance, a growth rate of 0% implies a company value of 1042, while a growth rate of 3% yields a valuation of 1350. In this example, the value added with growth compared to scenario with zero growth is 29.5%. A more extreme example results if we assume a growth rate of 7%. In this case, the value added with growth is 160.6% the value of a zero growth scenario. These tables further illustrate the impact of growth rates on the free cash flows. For instance, assuming a growth rate of 5%, the free cash flow in year 20 will grow to 2,653,298, which is 165% of the initial free cash flow with no growth. Assuming a growth rate of 10% yields a free cash flow in year 20 of 6,727,500, which is 573% of the initial free cash flow with no growth. This table illustrates examples of growth rates of free cash flows used in company valuation in the context of takeover offers for different target companies in Switzerland. We recognize that these assumed growth rates are between 1.20 and 2%. This table provides a summary of the DCF valuation approach discussed in this lecture. The DCF method can be applied for both the enterprise value as well as the equity paradigm. However, as we have seen earlier, the respective valuation formulas use different free cash flows and discount rates as input, but the computational method stays the same. A final point to highlight is the relationship between equity and enterprise value. The equity value is defined as enterprise value minus net financial debt. After having carefully studied session 1.1, please start with the review questions. The next session 1.2 will emphasize on calculating discount rates such as weighted average cost of capital WACC and required rate of returns on equity.